We have already discussed two modes of I/O transfer, program-driven I/O and interrupt-driven I/O. In program-driven I/O, the processor takes the complete control of the I/O operation. The processor itself checks the status of the device, whether the device is ready for the data transfer. If the device is not ready for the data transfer, the processor itself has to periodically check the status information of the device at regular intervals. That is, the processor itself performs a polling on the device, and when the device is ready, the processor itself has to perform the data transfer between the memory and the I/O device. In interrupt-driven I/O, we reduce the overhead to the processor a little bit. Here, the processor need not perform polling on the devices. When the device is ready or whenever the device needs some attention, it itself raises an interrupt signal to the processor. But the processor itself should perform the data transfer between the memory and the peripheral. So compared to program-driven I/O, this method reduces a lot of overhead to the processor by saving a lot of CPU cycles and avoiding busy waiting. But even then, the processor is actively involved in the data transfer between the memory and the I/O device. So the third mode of I/O transfer is DMA or direct memory access, in which we again reduce the overhead to the processor. Here the processor need not perform polling. Also, the processor need not actively participate in the data transfer between the memory and the external device. The processor just has to initiate the data transfer between the memory and the I/O. Data can be directly transferred between the memory and the peripheral without active participation of the processor. This is made possible with the help of a special purpose device called DMA controller in the I/O interface. The processor just has to initiate this data transfer by programming the DMA controller with all the necessary information required by the DMA controller to control the data transfer between the memory and the peripheral on behalf of the processor. Also, the processor, who is the real master of the bus, should release the control over the bus and let DMA controller be the master of the bus for a while to control this data transfer between the memory and the peripheral. So while DMA is controlling the data transfer between the memory and the external device, the processor should hold itself. So no need of context switching, no need of saving the state information and all, hence a lot of interrupt overhead is avoided. But anyway, while DMA is using the bus to control the transfer between the memory and the peripheral, the processor will not be able to use the bus, but the processor may able to perform some other useful computations. Also, by using one particular mode of DMA transfer, the bus can be intermittently used by the processor and the DMA controller, allowing the processor to continue with its work using the bus too. This can be used in case the peripheral is very slow. Finally, when the DMA transfer is completed, the DMA controller can notify the processor using an interrupt signal so that the bus control can be taken back by the processor.